So we're going to be looking at how to create an exponential function between 2 points. We did the work last class on how to find an exponential function in a table and how to find a linear function in a table. But I want to remind you that we know we're done when we have f of x equals, c a to the x. So that's how we know we're done. So we're going to have to find the initial value, that's c, and we're going to have to find the base, which is a. Taking a look at both of the two ordered pairs you don't have the y-intercept here. So you're going to have to go through a process which is called systems of exponential equations. And it should feel a little bit familiar because you did it with linear equations a long time ago. So what I'm going to do is I'm going to put this y value here in f of x. I'm going to put this x value here with the x in a system of linear equations. So the output is 12, and that's going to equal some c times a to the 1. And then I'm going to do the same with the second ordered pair. 108 equals c a cubed. And now I have two equations and two unknowns, and I'm going to use the fact that exponential functions have a common ratio to divide both of these equations by each other. So I'm going to set that up over here. I'm going to set it up, it doesn't matter how you set this up, as long as you make sure that if you're doing 12 divided by 108, that's this y value divided by this y value, that's going to equal c a to the 1, because this x value corresponds to that y value, over c a cubed. And what I hope you notice immediately is that the c's cancel out. That's literally the elimination step, and it makes everything else just a heck of a lot easier as we go along. So we take the next step, which is 12 divided by 108. That becomes 1 over 9. These c's have dropped, and I have 1a in the numerator, and that cancels with 1a in the denominator. So I have 1/9 equals 1 over a squared. I'm going to use cross multiplication. That's the tool I'm going to use. So I'm going to multiply across the equal sign. 9 times 1 is 9. A squared times 1 is a squared. Then I'm going to use the fact that to undo a square, I have to take the square root of both sides. And I'm only taking the positive square root, so I don't have to worry about the plus or minus. And that is a equals 3. And you're halfway there, because you needed a c and a to the x. So I've got an a. I'm going to go back to my original equations, and I'm going to choose one to shove my a back in. I'm going to take this one, and because I'm lazy, I'm putting it in here. But you totally could have put it in here and been fine. So that work looks like 12 equals c, which I still don't know, a, which I do know is 3, raised to the 1. Any number raised to the 1 is just the number, so that's 3. So this is 12 equals c times 3. Divide both sides by 3, and you get a c is a whopping number 4. And you're so close to being done. You are so close to the end of this problem because you have found everything you need for a c and an a. So all you got to do is just write the function f of x equals c times 3 to the x. What's lovely about this is these two ordered pairs create an exponential function, and here is that exponential function. You went through a process to get the c and the a to get this particular function. Let's go to the next one. So let's try this process again, except this time we're given ordered pairs that are in function notation form. So I know I'm done when I have f of x equals c a to the x. I'm going to create two systems of equations that model this. I can either put this into ordered pair form by reminding myself that this is -2, 3/4 and 2, 12. Or I can simply just take it out from this particular notation. I'm going to put 12 equals ca squared, making sure that my y and my x are in one equation, and 3/4 equals ca to the -2. And it doesn't matter what order, top or bottom, you choose. I'm going to leave it as is because my negative exponent will then be moved to the numerator when I do the division. So I'm going to create one equation to solve. y divided by y equals ca squared divided by ca to the negative 2. And this would be like x divided by x. I'm going to cancel the c's. They're going to be going. And I get over here in a tiny spot that 12 over 1 divided by 3/4 equals 12 over 1 times 4 over 3. I'm going to do the 12 divided by 3/4, by the way. Can't take 3 into itself once and 3 into 12 4 times. 4 times 4 is 16. And 1 times 1 is 1. So now that I have what y divided by y was, I come back and say, okay, I have a to the negative 2. Whenever anything has a negative exponent, it's in the wrong place. Currently, a to the negative 2 is living in the denominator. To get rid of this negative, I have to move it to the numerator. So I'm going to write a squared, which was already in the numerator. That's this one. And then I'm going to bring this up to the top and get a squared for a total of a to the 4th, which is nice. It all kind of looks nice when it's done, because I'm going to take the 4th root of both sides, and I'm only taking the positive root, and it happens to be that a equals 2. So I found a because I canceled c, and now I'm going to have to choose which of these equations do I want to shove a in. Do I want to shove a in the top, or do I want to shove a in the bottom? Because of this negative exponent and this fraction, I think it's going to be easier to solve for c if I put a in the numerator. So that looks like 12 equals c times 2 squared. And I didn't mean numerator, I mean top equation. So 12 equals c times 4. Divide this by 4 on both sides, and c is the number 3. And you're done. Because if you recall, you needed a c and an a, and then you have those two based on these 2 points, or ordered pairs, and your final answer is f of x equals 3 times 2 raised to the x. I would suggest doing this one on your own before you watch me go through it, because you've seen me do it twice, and you can kind of look back and think, okay, I see the steps that she's taking. So I'm not going to say pause the video and do it, but I'm hoping that you are pausing the video and doing it. Quick reminder, you know you're done when you have f of x equals c times a to the x. And the first step of this is to write a system of exponential equations, making sure that your y values go here and your x values go there. I'm going to start with the first ordered pair here, although it doesn't matter what you start with. The y value here is 1/2. That is equal to ca cubed. The denominator, or the bottom, equation is going to be 64 equals ca to the negative 4th. And I just wanted to point out that if this is in the denominator, it makes all the math a little bit easier, but you don't have to. You can always use cross multiplication, which is the same way I did on number C at the beginning of the slides. So setting this up so you can solve it, y divided by y equals ca cubed over ca to the negative 4th. Wonderful news, the c's cancel. They're always going to cancel. That's our very first step. Now I'm going to take 1/2 and divide it by 64 over 1, which is the same as 1/2 times 1 over 64, which is 1 over 128. So that's the y divided by y. Now I'm going to take this negative 4 and put it in the numerator. So I have the original a cubes that were in the numerator, and now joining them are 4 of the a's, getting rid of the negative exponent. So now I've got 7 a's. I'm going to take the square root, no, not the square root, the 7th root of both sides. And if you know your powers of 2, you know that 128 is a power of 2. It happens to be 2 to the 7th. So this becomes 1/2 equals a. And you're done with a. Well, let's go get c. So let's see, I've got a choice. I can put it in the numerator, And by the way, it is a, because I just found it. I can put it into the top equation. I don't know why I keep calling that the numerator. Or the bottom equation. I'm going to choose to put it in the top equation because I don't want to deal with a negative exponent. And so, without further ado, that looks like 1/2 equals the c that I don't know times the a that I do know raised to the 3rd power. Quick reminder, if this is 1/2 raised to the 3rd, that's 1 to the 3rd over 2 to the 3rd, which is why when you continue this, it becomes 1/8. To get rid of a 1/8 from both sides, you just multiply both sides by the reciprocal, 8 over 1. And on this side, I get 8 divided by 2 equals c, and 8 divided by 2 on a good day is number 4. And I found my c's. So I'm done. All I have to do is finish this out by saying the exponential function that goes between these two ordered pairs is f of x equals 4 times 1/2 to the x. A couple things I need to say right now. The way you check this answer is to take one of your ordered pairs and put y here and x here and make sure that it's true, and then check the other one and make sure that's true, because you're making an exponential function that connects these 2 points. So both of these 2 points should work. The next thing I want to say is this process takes time. In your supplement, it's supplement number 4-3, you will have the opportunity to do 6 problems just like this. I have a video for one of the problems just in case you get stuck, but I want you to refer back to this video when you're doing those problems. Don't forget, you have the answers, but not the process in the supplement. That leads us to what happens when you have the y-intercept. So if you notice, you know what happens when x is 0. The starting value is 8. So you already know right off the top that c is 8. But what if you wanted to treat it just like all the other ordered pairs, exponential functions, and remind yourself that you're done when you look like that? So that becomes 8 equals c a to the 0. And the bottom equation looks like 2 equals ca squared. But I'd like to focus your attention on this equation right here. Any number raised to the 0 is 1. So instead of writing a to the 0, you could have just written 8 equals c times 1. And c times 1 is just c. So you found 8 without doing any of the process, and that's the only time that's going to work is when you have the y-intercept. Now instead of substituting a into this original equation, now that you know c, you can substitute that into the bottom equation and get that 2 equals the 8 that you discovered c was, because it was the ordered pair, times a squared. So divide both sides by 8, and you get 1/4 equals a squared. Take the positive square root, not the negative. You don't have to do plus or minus in this case, and get that a equals 1/2, and you're done, because you have both a and c. So you are done with this equation that quickly because you knew the y-intercept, or you knew the starting value was 8, and all you had to do is go find what the base was. So we're going to do to exponential equations what we have done to every type of equation so far. We're going to solve it for x. What makes this tricky is you have the x in the exponent, and you don't have the inverse of an exponent yet to be able to get the x out of the exponent. So you have to use a trick called same base. Anytime you see this, I want you to think, I got to make same bases. And by base, I mean, if you take a look at this 2 and a look at this 32, they share a base of 2. So I'm going to make the bases the same. But before I do, I'm going to figure out how to erase on here. And I apologize for the pause because I don't know how to erase. No. All right, well, I'm just going to erase the slide there. All right, so I'm going to make 2 and 32 in the same base. It turns out this is really rather nice because 32 is just 2 to the 5th. Now, if you take a look up here, The whole point of this is if you have a base raised to something and that's equaling that same base raised to the other something, you can cancel the bases. That's what it means by same base. So it means that I can cancel the 2's because they have the same base and simply just look at the exponents. 3x minus 1 equals 5. I'm going to add 1 to both sides, divide both sides by 3, and get that my x equals 2. Because I'm solving for x, it gets curly brace notation. How do I check that? Shove that back into the original and make sure that 2 to whatever this is equal to 32. B is a lovely problem. And I figured out how to erase, by the way. B is a lovely problem because it's already set up in same base. So you have to recognize that the base of 5 cancels with another base of 5. And what you get out of this is x equals -6. And you're done because you solve for x. We're going to use same base over and over and over. I'm going to do some and leave some for you to do. You're going to bring in the ones that you were supposed to do on your own on it for class next class, whenever that is. I don't know, snowpocalypse is sounding like a real thing. So I have 2 more. I'm going to do C and leave you to do D on your own. I'm going to look for a base that 4 and 16 have in common. And I notice that 4 squared is 16. So rewriting that, I get 4 to the 2x minus 5 equals 1 over 4 squared, because that's what 16 is. The next thing I'm noticing is that 1/4 is not the same as a base of 4. I'm going to use the negative exponent rule to drag this 4 squared out of the denominator. And that looks like 4 to the -2. Because I have taken out this 4 squared from the denominator, and how I do that is I use this negative x notation, or negative exponent notation. Now I have same base. I can cancel the 4's and just deal with the exponents of 2x minus 5 equals -2. I'm going to add this 5 to both sides and get 2x equals +3. Divide both sides by 2. And x equals the beautiful fraction 3/2. Again, I'm going to leave D for you. This is a nice one. Really quick question though. If you have a 2 and a 4, do you already know what the base that you're going to use is? That's my question. All right, I'm going to do F because E is fun, and I think that would be fun to do at home. But F is fun, and I feel like let's do it together. Well, let's do it together, me in this tiny little room in a closed campus. All right, so notice that you have a 9, a 27, and a 3. Those are all your bases. You've got to figure out a number that has 9 and 27 and 3 in it. I'm going to start with the number 3 and kind of start listing 3 to the 1, 3 squared, 3 cubed, 3 to the 4th. Knowing your powers for this particular same base is going to be so much nicer for you. So getting through some of these powers and getting used to what 5 squared is and what 5 cubed is right at the tip of your fingers, that's going to be real help. But I'm noticing here that 9 is 3 squared. And that's raised to the 2x. And 27 was 3 cubed, and that was raised to the x squared. And then this already had the same base of 3 to the -1. So continuing this problem, you should notice that you have power to a power here and there. Power to a power means that you have to multiply the exponents. So this becomes 3 to the 4x times 3 to the 3x squared equals 3 to the -1. We need to talk about this because we can't use same base until there's only one base on one side and one base on the other side. If you'll notice over here, you have 2 bases. So we're going to need to figure out how to get rid of all of the either this base or this base. We'll take a look at their exponents. There's a property of exponent rule that says if you have a number raised to a power and you multiply that by another number raised to another power, to be able to add up how many of these you have, you just add the exponents. We used multiply because it was power to a power, but this is power times a power, which is exactly what I have over here. So I'm going to take the base of 3 and raise it to the 4x plus 3x squared, and that equals 3 to the negative 1. And I finally have one base to cancel with one base on the other side. So that gives me just the exponents of 4x plus 3x squared equals negative 1. Anytime you see quadratic, you've got three choices. Factor, you can use completing the square, or you can use the quadratic formula. I'm going to choose to see if I can factor it first, and I'm going to move everything around. So it isn't equal to negative 1, it has to equal 0. And so moving everything around looks like 3x squared plus 4x plus 1 equals 0. You should be able to factor this as 3x plus 1, x plus 1 equals 0. And I'm going to move this over here. When I do, I get that 3x plus 1 equals 0, or x plus 1 equals 0. And when I solve this, this becomes negative 1/3, and x equals negative 1. And that is the answer to that. That was fun. I like that one. I'm going to do one more. I'm going to leave you with H because H is another good fun one. And I'm going to do E because I really felt like the last time we talked about E, there were some students that were like, E what? I'm going to treat E as its own base because it is its own base. And I'm going to notice that there seems to be nothing wrong with the left side of the problem. It's this one and this one that I got to fix. I don't want E in the denominator, so I'm going to do the same trick I did before and utilize that negative exponent to bring 3 out of the denominator. Then I'm going to utilize power to a power and write e to the negative 4x. I cannot use same base. I have to wait until I have exponent equaling exponent. I'm going to add the two exponents here, negative 3x plus negative 4x. And now I can use same base because I have e and e, and that becomes, just looking at the numerators, 2x minus 1 equals negative 3 plus, or negative 3x plus a negative 4x. Good news is that's negative 7x on this side. And then 2x minus 1 on the other side. What do I want to do? I think I'm just going to subtract both sides by 2x. So once I do, I have 9x on the right, and then I'm just going to divide everything by negative 9. And my x is equal to a positive 1/9. And because it's an x and not a y, it gets curly brace notation. So doing same base is really the only way we have right now of solving exponential equations. We could put them in Desmos and put the right side, or excuse me, the left side as the first function and the right side as the second function and see where they intersect. But I think right now using same base is going to help us set up for how to find the inverse of an exponent. And that's going to be the subject of the next video. I want to wish everybody happy fun times. After you finish this video, I would strongly suggest doing the supplement 4.3, and you only have to do one problem from that, and then doing the homework from section 4.3 from the email I'm about to send out to everybody. Be safe.